and you're live.
Hi everyone, I hope ye are all having a fabulous Maths Week 2020. There are over 360,000 of you registered so far to take part in events all throughout the island of Ireland. And that's over 4 times the size of Croke Park, which is absolutely fantastic. If you haven't registered yet, please get your teacher to do so over on our Maths Week website. It has been absolutely fantastic to see all the brilliant and creative work that all you guys have been doing and your teachers have been sharing with us these past few days. And fair play to you all deserve a really, really good pat on the back. So later on Maths Week TV, we will be running a teachers event with Bobby Siegel tonight at 6 p.m. So if you'd like to sign up, you can do so on Maths Week TV on our event page, and that will be dealing with how to bring your maths lesson to life. But here with us today, we have our fabulous live audience with Maths Week TV. So we have Kilorgan Educate Together National School in County Galway. Hi guys, how are you? We have St. Saviour's in County Waterford. How are you? And then we have Holy Cross National School in Killarney. So without further delay, I would like to introduce Dr. Ken. He is one of the best maths presenters out there today, and he has a fantastic show which will present a huge array of maths tricks from mind reading to virtual juggling patterns. Now, usually Dr. Ken performs both on the north and south of the island of Ireland, but we are very lucky that he is able to be with all of us here today, with schools participating all across Ireland. So if y'all would like to give a big boolabus for Dr. Ken and his mathematical show, It Doesn't Add Up.
Hello everyone. It's so good to hear you. Oh no, I can't hear you. See you. Yeah, wave. It's like silent clapping. Silent clapping. I can hear you all the way here in England, all the way there from Ireland. That's absolutely wonderful. So we've got a very cracking show for you today. I'm doing all sorts of mad things. Now I've got lots of technical things. They may go wrong. Hopefully, fingers crossed, they won't. It may get confusing as I change cameras, but don't worry. I'll try and explain where all this stuff is coming from. So let's start off with a crazy bit of maths. Let's have a look here. Can everyone see that? I've got some liquids. And I thought I'd start with a little bit of maths science, actually, because look at this. This is called a measuring cylinder where we measure liquids. Okay. This is called a conical flask. Again, you measure liquids in there. And this is called a jug. I know, this is you probably, or a beaker. You've probably seen this before. Now, I've got some liquids in there, and a quick question. I want to know which has got the most liquid. Now, before you go, I'm going to get everyone to show their hands. Actually, hands up if you think this one has got the most liquid. Hands up if you think this one has got the most liquid, and hands up if you think it's the correct one. I mean this one that's got the most liquid. You see what I did there? You got suckered in there. You got suckered in there in red. Can you believe it? Now, there's a couple of questions I didn't ask you. I didn't ask you, do they have all the same amount of liquid? I didn't ask you, do two have the same amount of liquid? No, because I was a bit tricky like that. And the truth is, you're probably not surprised to find out, trying to trick you, they are in fact all the same liquid. It doesn't matter which one of these, they've all got the same. I'm going to prove it to you. I'm going to come up to, I've got this camera up here. I'm going to show it to you. Can you see on there? I'll try and get it flat. It's there. Here is there. And here. Oh, let's try and get it there. Probably not a great light, but they're all the same. It doesn't matter which one you've got, they're all the same liquid. Now, the thing is, there's a couple of things here, is that when you've got something tall, because liquid fills up a volume, okay, it takes the shape of the container. You can see when it's tall and thin, it goes up high. When it's short and wide, it doesn't go up as high. And it's very strange when it's got these sort of diagonals in as well. This one actually is the most accurate. Because it is short and narrow, what it means is if you have a small difference, it's a small error in volume. This one's got the biggest error. This one is better than this, but not quite as good as this. So these are all used for measuring, and it all depends on how accurate you want to be. Now I'm going to go over here. I've got some other things for you. So, all right, they're all the same volume. Hey, I've just spilt something. Right, here we go. Oh, okay, I've got some containers here. Okay, so we've got this container here, this container here, this container here, and this container here. If I show you all of the containers, you're probably thinking, Dr. Ken, there's 4 containers and they keep going down in size. Well, I'm going to show you something. Just watch very carefully. I know, they're both the same volume. Let's see what happens when I put this one in here. I know, they're both the same volume. Any idea when I put it in here? Look, this one here. I know, yeah, I know, it's going to go everywhere. This is where it's all going to go wrong, isn't it? I know, can you believe it? So this one and this one, these two have exactly the same volume. So all I have to do is put it back in there and we start again. So just like the last trick where I took objects which appeared to have different volumes but had the same volume, I've got these objects here which also have the same volume but don't appear to have the same volume. So it's kind of like the same trick. Now this is a very famous magic trick. And you're thinking, Dr. Ken, how do you do that? Well, obviously I do it particularly well, but I'm going to give you the maths behind this. And I want you to think about it. I want you to get your pencils and pens, do this later. And I want you to draw a beaker and think about the volume and then go, I wonder how I could draw another beaker, which is a smaller one, but has the same volume. And think about what you need to do to alter one or the other so they have the same volume. So that's the clue I'm going to give you. And if you come up with a solution, then don't forget to put it in the Maths Week website. Okay, so do your homework, do your drawings, and I think there'll be an opportunity where we'll find out at the end where you can send it. So just remember to do that. That's my homework for you today. All right, a couple more things. I've got cans here. This is a can of classic Coke, classic Coca Cola. I can see you're all getting excited. Memories of the weekend. Yes, I know, classic Coca Cola. I was traveling in Kuala Lumpur and I noticed this one. Look, it's a classic Coca Cola. Yeah, it's differently spelt, but it's also a different shape. Can you see that? One is tall and thin, and one is short and wide. So my question is, yes, it's that same question, which one has the most volume? So let's have a show of hands. Someone's leaving, they've had enough, or a fire alarm. Hands up if you think it's this one. Hands up if you think it's that one. All right, I'll do it. Hands up if you think they're both the same volume. People, I can't believe I've fooled you again. Let's have a look, because it's actually written on the side. If I get this up here and show it to you, let's have a look here. Can you see that volume there? Hang on, let me go to the other camera. It's a little bit easier to show you. Let's have a look. It is here. Oh, it's up there. There you go. Can you see that? 330 mils for this one. This is the short wide one. And for this one, can you see? It's 320 mils. So one is 330. This is 320. So there's 10 milliliters difference. And yes, I was annoyed. I thought they had cheated me, giving me less Coca Cola with this one. And I thought, but why? Why have they cheated me? I've gone all this way to Kuala Lumpur and they cheated me in the amount of Coca Cola. So I started doing the maths. I started thinking, okay, what are you buying here? Well, you're buying a can of Coca Cola. So you're buying Coca Cola and the container. So I started doing some maths thinking, well, okay, if I can work out how much aluminium's in this can and compare it to this can, I might get the answer. So I thought, oh, I know what I could do. I could get the surface area of this round bit here, and the surface area of here is quite easy because you just cut this up and cut this up. It becomes a rectangle, or I could do a very, very simple bit of maths. I could just weigh them, and if I weigh them, then that's a measure of how much aluminium is in each one. So let's have a look. So I've got my scales, and I've got a camera over here. Let's see if you can see this. I'm going to pull this down here and just adjust this here. Okay, so that is zeroed up. So I'm going to take this can here, which is the small can, and you can see it's 12.5 grams. Then I'm going to take this can here, which is the tall can, and you can see it's 13.8 grams. So in other words, there's more aluminium in this one compared to this one. And that's why you get less Coca-Cola, because you spend the same amount of money on each of them, but you're paying for more aluminium. But why? Why do they make these ones then? Because people will feel cheated. Well, there's a reason, because more of these, because of the shape of them, in the refrigerator. It's a hot country, and they probably drink a lot more Coca-Cola than you or I do, because it's so hot. So there's the maths behind it. So all right, let's do some other maths. Let's do a card trick? Hands up if you like card tricks. Card tricks? All right, and well, okay. I'm going to do you a mathematical card trick. And the thing with a mathematical card trick is that there's often a lot of counting involved. So I thought I'd try and get you guys involved. Okay, so I'm not sure how we're going to do this, but let's get my camera set up so you can see this. So I'm over here. So if I swap it over here, you can see here's the cards. I'm going to take the cards out so there's no cheating going on. I'm not a great magician. This is all pure mathematics. And what I need from you guys is a number between 10 and 20. So I need, we're going to do this a few times, so I should be able to choose a few schools. So I do not know your school names, but I do know your teacher's name. So someone put your hand up who wants to give me a number between 10 and 20. So I'm going to go to, now, is it Miss Twomey? Miss Twomey, yes, that's how I say it. Could you pick someone, and get a number between 10 and 20? You can put the mic on, yes. They can shout it out so I can hear it.
19.
Thank you for that big number. 19. Okay, 19. So this is what we're going to do for this trick. I'm going to count out 19 cards. Now, I didn't tell you to choose 19. I don't know you. Okay, this is a free pick, but I will count out 19, and I'm going to do the same thing each time with different numbers. Okay, so I count out 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And you'll be able to do this at home. So I've got 19 cards here. Now what I want you to do is we're going to do something with this packet of cards. And this is what we're going to do with it. We're going to put some back. The number we're going to put back is dependent on the number you chose. Now you chose 19. So I want you to take the tens and the units and add them together. So that's the 1 of the 10 and the 9 of the units. Add them together. 1 and 9 is, anyone? Oh, down here, Mrs. Doyle's class, they have their hands right up. So, 10, yes, correct, 10. So now I take this lot and I'm going to pick it up without doing anything here. I'm just going to count 10 back. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the card selected is this one. So I'm just going to put it there. So, okay, you're thinking that was pretty counting. So, all right, let's do it one more time. Let's do it one more time, then I'm going to explain the trick. So, I need somebody else. Somebody else give me a different number between 10 and 20 again. Different number, not 19. Okay, Miss or Mrs. Healy's class, could you choose someone, please? Choose someone, that'd be lovely.
Hi, everyone. Okay,
Hello.
so 15, please.
15. Oh, what a great number, 15. So I'm now going to choose 15. So I deal out 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I put them down. I now pick this packet up. I've got to add up the tens and the units. So 1 and 5 is... Oh, Mrs. Healy's class again. That was so quick. What is the answer? 6. So then I just put 6 cards back. 1, 2, 3, 4, 5, 6. And that is your selected card. I put that back. Now, wouldn't it be amazing if I turn these two cards over and they were exactly the same? What are the chances of that? In fact, the interesting thing here is you could have picked any number between 10 and 20. So if you'd have picked 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then you would have had to take 1, 2 back. That's your card. Look, that's also a jack. This is like how I'm going to explain how, people. I'm going to explain. If I just put up this. Okay. Look what I did each time. I asked for a number between 10 and 20. So you could have had 11, 12, 13, 14, 15, 16, 17, 18, or 19. And then if you add the two digits together, you get 2, 3, 4, 5. And if you just look at that calculation, if I take one from the other, you always get 9. Now that's the maths behind it. Now I'll just demonstrate why that works in this trick. So if I do that again with 11, I go, well, no, we'll do it 12 this time. So I count 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And of course, all I'm doing is I've got 12 cards here. I'm putting back 3, 1, 2, 3. Okay, so that is the 9th card. And of course, surprise, surprise, it's another jack. So all you've got to do is always have the 9th card as the card that you want, then this trick will work. So hands up if you think you'll be able to do this at home. Brilliant. So your homework is to get a deck of cards and try this. Try and do this. Try and do this trick for your folks at home. If you've got any brothers or sisters, maybe some family at home, see if you can do it. It's a really fun trick and a really simple piece of maths. Okay. Oh, back in the room. All right. Let's do a really simple, very simple trick. A bit of algebra. You can all do this. You might. I know. Oh, all right, people. All right. I know I've said the A word. Not abracadabra. Algebra. I'll show you the algebra after and how it works. So let's do a simple trick. I want you to think of a number. You can all do this. If you need to do it in your head, brilliant. Sorry, if you need to do it on a piece of paper, fine. If you can do it in your head, super fantastic. Let's see how your mental maths is today. So think of a number between 1 and 10. Okay, you've got the number between 1 and 10. Okay, then all I want you to do is double it. Double it. Yes, double it. Okay, you've doubled it. Now all I want you to do is add 10. Oh, that's good. I see we got some brill masterminds here. Now all I want you to do is take away 2. Take away 2. Okay, now you've got that total there. Could you half that total? Can you? Is everyone still with me? Right, half the total now. And then if you can remember it, take away the first number you picked. Okay, you should have a total. Okay, we can drum roll this. Drum roll, don't tell anyone, Hands up, who got 4? Everyone. Hang on. Just tell everyone what number you chose. Did you all choose the same number? What, am I some sort of mind reader? Has it? All right, let me explain the algebra here. This is why it works with algebra. Okay, so with algebra, oh, it's all getting weird. So here we have my famous algebra to the side here. Hopefully, if you look at this on the screen, instead of picking a number, you picked a letter. So you chose a letter X, and I said double it. So of course it would become 2x. And then add 10, it would become 2x plus 10. And then I said take away 2. So you take away 2, it becomes 2x plus 8. And then you half it, so it becomes just x plus 4, and then you take away your original x, and of course then you've got 4. So just by using simple algebra, I forced you to choose the letter 4. Now you may have seen this trick where you then take that letter 4 and you get someone to think of a letter from the alphabet. So you say, oh, whatever your number is, count forward from A, B, C, D. And so 4 would be a D. And then they'd say to the person, yeah, and then pick a country in Europe that starts with D. And then everyone goes, well, I only know one. That's because there only is one. So they then forced you to choose. Yeah, exactly. Someone's laughing. It forced you to choose the country Denmark. See how the sort of mathematics has forced you to do a little bit of magic. So anyway, play with that. See if you can do that one at home with your folks. Okay, I've got another trick here I want you to do. Get a piece of paper. Okay, piece of paper. Everyone got a piece of paper? Can you see this piece of paper? I'll show you what I've got on it. Okay. Oh, this is what I've got on it. I've got an arrow and I've got a protein. And I wrote this routine. Oh, sorry, and on the other side is nothing. And I wrote this routine because proteins, you've probably heard of proteins. They're kind of big things that we often eat, like fish and meat, and they take a long time to break down. And they move. So proteins move like this, they move like this, they move like this, they move like this, this, this. But the reason why I've chosen proteins is they fold. Okay, so I've got an arrow here. So if you want to put an arrow on your piece of paper, so if you have it landscape like this, and you put an arrow on it, and the arrow should be up. Okay? And you can do this with me. So all I'm going to do is fold it. Okay? So I'm folding it because proteins actually fold. As well as moving, they fold. So I folded it once, I folded it twice, I folded it 3 times, and then I've unfolded it, I've unfolded it, I've unfolded it, and look, it's pointing up. Now, you're probably thinking, Dr. Ken, that is pretty boring. But the thing with proteins is sometimes, if you just put your papers down, just watch carefully this time. Sometimes when you fold them once, you fold them twice, you fold them 3 times, and then you unfold them once, you unfold them twice, you unfold them 3 times. Can you see the arrow has rotated? So sometimes when you fold it and unfold it, it doesn't. But other times, when you fold it and unfold it, it does. I know, it's weird, isn't it? So how is that done? So I want you to investigate that. It's a lovely piece of maths that I want you to investigate. You've all got a piece of paper. It's the cheapest piece of maths today. Why is this relevant? Well, it's relevant because proteins do fold and unfold. And scientists are actually studying the way they fold and unfold, because if a protein doesn't fold correctly, sometimes you get diseases like Alzheimer's and cancers forming because of that folding and unfolding mechanism. It's a little bit more complicated in a protein, but this just shows you that maths is involved so heavily in science. So don't forget, I can see you all doing it. Fold, 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 unfold, unfold, and see if you can make it rotate. Hands up if you think you're able to do this at will. Who is Will? Do you have a will? No, not Will. That's a joke. Okay, if you can do this at will, practice, 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 and then that's another trick that you can take home, and then try and come back tomorrow and explain the mathematics to your teacher and to your class. See if you can work out how come this is actually rotating. How come this is actually rotating? That is your clue for today. All right, final tricks. I've only got about 1 minute. One more minute. We did say a bit of juggling, patterns and juggling. So I'm going to do a bit of juggling, and I'm going to quickly explain how mathematicians got involved in juggling patterns. So if I just do some juggling like this is pretty cool, and I do a few tricks, and I just shout them out. This is Japanese robot, off his head, off his head, off his head, under the arm, under the other arm, under. Oh, this is Mill's mess. This is a shower. You can shower the other way. This is the box. And there are so many tricks. The trouble is remembering them, because there are so many different tricks. So mathematicians got involved with this and thought, well, how can we set up a system where the throw is represented by a number? So let's look at this basic pattern. This is called the cascade. Let's look at what's happening. When I throw an object, look, I'm going to start with the green one. I go green, blue, red, green, blue, red, green, blue, red. So that's green, blue, red. I could get some blocks. And these blocks, I could put them up as green, blue, red, green, blue, red. And that would make a really awful tie. So that's a pattern though, and it's called a repeat pattern. It keeps repeating. I can substitute numbers for those throws. So I could go 1, 2, 3, 1, 2, 3, 1, 2, 3. So the green one is every third throw. And they started a system and went, well, that's every third throw. That'd be number 3. And the different types of throws should be different numbers. So, okay, wonder what a 4 is. Well, okay, let's have a look at this. Look at the green one here. If I go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, you can see that's every 4th row is different to a 3 because they go this way, a crossing, so it's in each hand. Okay, that works. What about a 5? 5. Okay, oh, I need another one. I need 5. And it's got to be different to the 3, because I know the 3 is here. So it's actually just the same, a little bit higher. So if I start counting with the green one, oh, start counting with the green one. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Oh, thank you. Thank you. Thank you for applauding. That's lovely, lovely, lovely. I can hear you all the way here in Norfolk. It's a long way. So that's 5. What about 2 and 1? Well, 2 and 1, turns out that was a 2, just holding it or throwing it like this. A 1 was where it goes from side to side. So like that. And a 0, oh, this is my favorite. You're going to love a 0. Check it out. See, look, it's an empty hand. That's a 0. Very important for tricks like this is where it's called a flash, where you have 3 5s and 2 0s. And because it's maths, they could write down all the different numbers instead of going like, what was that trick called with the And there was no, when I started juggling, there was no videos. You couldn't go on YouTube. And that's why the maths came up, because we didn't have the technology around. I guess if we'd had it, maybe someone wouldn't have developed it any further. It's maths. You can play with this maths. And believe it or not, they came up with some new tricks. This is called a 4-4-1. 4-4-1. And it looks like this. And in fact, they're all doing 4-4-1, and it just looks like a complicated trick. So I know as a juggler, oh, thank you very much. I know as a juggler, I'd never juggled that before and thought, wow. And I got really into the sort of mathematics of juggling as a result. Well, unfortunately, everyone, we have come to the end. I know, I'm not sure whether you're great. Oh, yes, you can applaud. Yes, yes. In fact, why don't you just everyone put the mics on? I'd love to hear that applause. Bask in the applause. Oh, you guys are lovely. You have been absolutely wonderful. And thank you so much for tuning in today for Maths Week TV. It's been an absolute pleasure. Do try those tricks at home. Do try them on your friends that haven't seen this and see if they can work out the maths behind it. Now, I know we've got a few minutes for questions.
Okay, so that's good timing, actually. Very good timing.
They're not compulsory, though. It's not a problem.
Okay, we'll leave me.
You know when he's doing the juggling?
Yeah.
How long did it take him to learn?
Oh, if you can get your teacher to relay the question, that'd be lovely. Yes, is it Miss Healy, Mrs. Healy?
Yes. We have a question from Amber. Amber, do you want to say it out nice and loud?
How long did it take you to learn juggling with mathematics?
How long did it?
Okay, so the juggling took longer than the mathematics of juggling. Oh, well, actually, no, because of course I learned mathematics just like you did at school. It was one of my favorite subjects. I used to love maths and chemistry were my two favorite subjects. And I got into juggling as a hobby because I just saw it on the TV. There was a program called Blue Peter, and one of the presenters went to a circus, and the next week he could juggle. And then I started going to juggling conventions, and this came up in conversations when one of the jugglers said, "Have you seen this sleight swap?" which is what this is called. And then suddenly it just exploded. So I've been doing this for a long time, and the more you do it, the more you find out. There's another thing I'd love to show you. It's a virtual reality, but it doesn't kind of work in this format. And I use this virtual reality, the sort of the computing, to actually visualize the tricks. And because it's like virtual reality, you can actually get a graphic of a juggler actually juggling and doing the tricks, so you can see what they look like. Because sometimes it's difficult if you're going, I've got to do a 5 and 9 followed by a 7, and you get all your timings wrong. But when you see it, you're going, ah. And because it's virtual reality, you can see it from the front and you can see it from the back. It's amazing.
Oh, so we just have time for one last question, and we have one from Killorgan Educate Together School, and they would like to know, what other objects can you juggle?
Oh, what other objects? I can juggle, well, I can juggle fire. I have juggled real fire, balls of fire. I've juggled fire torches, knives. I can juggle. I've just got a new object that I'm juggling. Actually, it's a new invention, new piece of technology, which is sound sensitive. Every time you juggle it, it sends a signal to your mobile phone, which is a sound. So it could be a drum. It could be a space invader. You could program the sound, and you can create, so you can juggle and create music and weird sounds at the same time. So that is my favorite thing. I've also got some clubs, some juggling clubs that that change colors when you catch them, and they're programmable. So and they talk to each other. So you can throw one and then they can be all different colors, and so you bring them together and they all become the same color. It's an incredible, the way it's going in juggling, the technology is incredible.
No, that is fantastic. And I'd like to give a big round of applause for you all and Dr. Ken for joining us today on Maths Week TV. And don't forget to share all your homework with us on our website, mathsweek.ie, and our social media channels. We'd love to see all the homework that Dr. Ken has given you today. And you've been a fantastic audience, and we will see you all again soon. Thanks very much, guys. Have a lovely day.
See you later, everyone.
Super stuff. Well done.